All right, let's finish up this review. So here we're asked about the modern model of the atom. So the modern model of the atom was formed by many scientists over a long period of time. We can recall that some of those scientists were Dalton, Thomson, Rutherford, Bohr. Now, the next question, we see the wave mechanical model. Wave mechanical model is the modern model of the atom. And so we're asked about the orbital. Is a region of space where you have a high probability of finding the electron. So orbital is another word for the electron cloud. Circular paths are called orbits. And the orbit was described by Niels Bohr in his planetary model, though we know that electrons are not found in orbits, but instead are found in clouds. So the next question, we're asked to look at valence electrons, or outermost principal energy electrons of element X. So element X, its valence electrons are always going to be located to the right. And that would be 2. Now, the next question asks us which electron configurations represents the excited state of calcium. So let's pull up calcium from our reference table to look at this further. So here, when I look at calcium, I see that calcium has an atomic number of 20. So it has 20 electrons. We can add them up. 2 plus 8 plus 8 plus 2 is 20. So if we were looking for calcium in the excited state, we have to have a sum of 20 electrons. That means that element Z cannot be calcium. So we're between element X and element Y, both of which have 20 electrons. But the electron configuration on the periodic table is always the ground state. So X is the ground state. The electron configuration of Y has a sum of 20 electrons that is different from that on the reference table. So element Y must be excited. The next question, we are given the bright line spectrum containing a mixture of 2 elements. We're asked to identify the 2 elements. So it's very important that we look for 2 elements in the unknown spectrum. So we're simply going to do some matching. So here we have this line, and this line corresponds with helium. So we're going to look for more lines that correspond with the spectrum of helium. And we're simply going to mark them. Now we have to look for the next line. So in the next line, here we have this line, and we have to find the corresponding atom. This line corresponds with hydrogen. And we'll see that the rest of the lines also correspond with hydrogen. So here in our mixture, we have helium and hydrogen. Lastly, it asks us, explain how the bright line spectrum is produced in terms of excited state, energy transitions, and ground state. So when I write my explanation, I'm going to include the term excited state and the term ground state, and I'm going to describe the energy transition. So here we have electrons in the higher energy, in the excited state. So we can see that I've incorporated that term. Transition to a lower energy. So this shows the energy transition to the ground state. So I'm using that word to emit energy in the form of light. So I make sure that you hit all of the terms that they ask for in a free response question. In the next question, they ask us in terms of atomic particles. So you could use the term atomic particles or define an atomic particle. We know that atomic particles include protons, neutrons, and electrons. So a difference between isotopes in terms of protons and neutrons and electrons would be that they have a different number of neutrons. Recall that when calculating the average atomic mass, you're going to take the percent abundance and multiply that times the atomic mass. Here they gave us the exact atomic mass, so we'll use that. Now, after we do our multiplication, we have to recall that these are percents, and all percents are out of 100, so we're going to have to take our equation and divide it by 100. The next question asks, based on the natural abundances, the average atomic mass of neon would be closest to what whole number? So we can see that the largest percent abundance is 90.9. And that corresponds with this mass. And this mass is closest to the mass of 20 atomic mass units. This concludes the review for the atomic structure test. Good luck!